Right, welcome back to ArmanisMath. Today we're going to focus on solving linear equations and inequalities. Solving linear equations and inequalities. All right. Here's the warm-up. So I want us to spend about a couple minutes here. I'll put the timer. I'm not going to wait until 2 minutes, but that's for you when you watch afterwards. So a couple minutes. Make sure that you attempt all problems. I need to see whiteboards. Right, I'm going to pause it here. So when you evaluate this expression, when you are substituting x for 3 and y for -5 on each of these, I see one. I need to see more answers though. So I see one of them is basically what you're doing is substituting 2 times 3 in this case. Minus the -5. So it becomes 6 plus 5, which is 11. Okay, what you got for number 2? Okay, see that, Lindsay? Got that. That's good. Anybody else? I've seen -21. Okay, this one says write each expression in the slope-intercept form. Slope-intercept form we should know by now. It's y equals mx plus the b. And b is the y-intercept. Where is your line touching the y-axis? So go ahead and massage, bake, turn, toss, and then come up with y equals mx plus b from number 3. Can somebody give me that also in the chat? And a whiteboard is probably the easiest, so I can see mistakes. We work on them. I've got 2. Okay, so I'm seeing a couple things here. I see a y equals, this guy would lead itself into y once you do the, once you you guys, you could, in this case, you could just add the 4x's to both sides, right? And then divide by 2, y is going to equal to 2x plus 1. Okay, I see that, Donovan. Okay, and the second one, and number 4. Somebody just do number 4 with us. Somebody do number 4 with us. I'll need to see more, much more of you participating, not just 1 or 2. Actually, I have more than 10 right now, but I need more. Okay. Y equals 3x plus 2. How did you get that, Natalie? How did you get that y equals 3x plus 2? Do you want to show me with the whiteboard? Or the mic, that's fine. Oh, image is lacking? Okay. So I thank you up there. So I'm gonna, because this is a y, I need to have this on y equals. Probably could just, maybe you could add 3 y's to both sides. That would work. Or you also could subtract 9x's from both sides and then divide by -3. It's up to you, which doesn't really matter which one you pick. But let's say, for example, I wanted positive y's. So I'm going to add 3 y's to both sides. And that's going to give me a 3y on this side minus 6 equals 9x's. I'm going to add 6 to both sides. And that should give me 3y equals 9x plus 6. Divide that by 3. Y should equal to 3x got plus 2. So that should work. Okay? Awesome. Here's some answers here. All right. Is this window open or closed? It actually depends. Could be open, could be closed. It depends on your perspective. That's why we have to respect each other, even though we have different perspectives in life. We just have to respect each other's perspectives. And always remember, there's always another side of the story. Okay, objective. I will be able to solve system of 2 linear equations or inequalities algebraically and interpret the answer graphically. Okay, can somebody pick, actually all of you, pick one word from the objective. Choose a word from the objective. Question, equation, to interpret system algebraically. Yep, that's all we're going to be doing today. All right. Where actually in real life do you use this kind of stuff? Well, one real life example is, for example, if you have two companies both offering, giving you a job offer. One says that you have, we were going to pay you $450 per week. And the other one says, we're going to pay you $10 per hour. And both ask you to work 40 hours. So which one are you going to pick? Which one is going to be better pay for you? Well, that's what you use system of equations to solve that kind of a question and find out which one will give you more. Here's some vocab. That's way too much. It's one thing at a time, okay? So is my curtain. All right. So let me go through this one thing at a time. A system of linear equation is a set of 2 or more linear equations containing 2 or more variables. Okay, so this means you're not just saying y equals mx plus b anymore by itself. You actually have 2 equations of that, or sometimes 3 equations of that. And maybe 3 equations would have also 3 unknowns like x, y, and z. And you indicate a system by using a curly bracket before you start writing your system. So it's a curly bracket, and then whatever the first equation is, y equals, let's say, 2x plus 3, like the one that we had on the 2x plus 3. One we had on the warm-up, right? Y equals 2x plus 3. And maybe another one is y equals just x. That could be another one. Maybe a third one, etc., etc. Okay, an order pair. An order pair is simply a set of coordinates that can be graphed as a point. Basically, they're saying this is a x and y point. 2, 3, 5, 6, 0, 0. Okay. And the next one is going to be the solution. What's a solution to this system? How do you solve a system? Well, you solve a system when you have an order pair that satisfies, that works for both equations or 3 equations, whatever the number is. So once again, a solution to the system would be a point that you're going to find to solve and to be to satisfy, meaning when you plug it in, it's going to make sense in the system. Down here it says if an order pair is a solution, then it will make both equations true. Meaning when you plug it in, it's going to work for the first and the second, and if you have 3 equations, it has to work for all 3 of them. Not just one, not just the top one, but actually has to work for the entire equation. Okay. Before I leave this here in your whiteboards or the chat, give me an example of an order pair. Give me an example of an order pair. Here we go. All right. Here is a system that you're looking at here, and this system has a curly bracket, as I said. This is a curly bracket. Here's that. That's how you start writing a system. Here's this curly bracket here, like this. And then you list your equations. And it says here that this point of intersection, the point of intersection here, 2, 3, is a solution. So basically, if you want to find a solution to a system, you're looking for the point of intersection. Where do they cross? Where do they meet? Where do both of them cross roads? That is your point of solution. This is a solution to the system. So how do you make sure that the solution works? Well, you have to plug it in again. And remember, you've got to plug it in the first, and it has to make sense. You have to plug it in the second, and it has to make sense as well. So Armani, whatever, it just works for one of them. Guess what? It's not a solution. And right then, it's not going to be obviously crossing. If it's not a solution, they're not going to be crossing. Okay, sometimes it's difficult to tell whether the lines cross when you graph. That's why you check your answer by substituting the point that you got into both equations or 3 equations or whatever number of equations. Here is a starting point here. It says solve the system by graphing and check your answer. So if it does indicate I need to solve by graphing, guess what? I've got to graph. So let's try to graph this one here. Y equals x. I could graph this one. If you know about angles, you know that this is a 45-degree angle. This is actually a 45-degree angle line. But if you don't, it's not a big deal. Make yourself a short table here. And x and y, as we done that in the past. 0 for x. If I put 0 for x, this is just kind of an echo function. You see, ha, says ha. Hello, says hello. So you put 0, it's going to give you 0. If you put 1, it will give you 1. If you put -2, it's going to give you -2. Okay, that's just the way it is. So now I guess I know how to graph this dude here, because this one is pretty simple. 1, 1, 2, 2, 3, 3, 4, 4, etc., etc. So 0, 0 obviously is one of them. 1, 1, 2, 2, and then you keep going with that concept. And I'm probably going to choose this green color here. So I'm going to choose this color here. Okay. Remember, it goes all the way down to the other direction as well. So this is the first equation, y equals x. Y equals x is a 45-degree angle line. This is 45 here. Just in case if you're interested in bringing some geometry into this one. Y equals mx plus b is the second one here, and this second one, by the way, I'm also a big fan of labeling my equations. So this is equation number 1, this is equation number 2, and for this one also I'm going to do a table. You actually could do a table, or you could not do a table, because if you use y equals mx plus b, you know that you're going to start your graph where. Can somebody tell me where should I start my graph here? For number 2, where do I start my graph? Yellow. Okay, so I could actually start at -3. So I'm going to go back here and then put that at -3. So it's a 1 and 2 and 3. I'm -3 here. And then I want to do what with the slope? What would the slope help me with? The slope here. What's the slope, by the way? What's the slope? M equals what? Come on, guys. We need to pick up the pace, please. We've got a lot to cover. The slope, by the way, is just the number next to the x, okay? Not the x itself. This number next to the x. It's called the coefficient of the x. So what is the coefficient of the x? What's the... Yep, just that. And for you to use this for slope, you just put 1, which means, are you going to go up or down here? Up 1 or up 2 or up, right, left? You're turning into... okay, Johnny, focus. You might need to reboot. Okay, guys, come on. Up, down, left, right. Up, down, 2, right, 1. Thank you. Down 2, right 1. So down 2 is 1 and 2, right 1 is here. And this slope of this line is going to look. That's not green. I don't want green for this guy. I want black for this thing. So it's going to look like this. Okay? And obviously I don't have a grid here, but they will intersect at one point. Yeah, these two are going to intersect at this point here. If you have a grid, it's easier for you. If you found it, let us know. Okay? But that point, the one that you're going to find, will actually have to satisfy both equations. So if I graphed it here very carefully, I'm going to end up at -1 being the point. And at -1, that's the solution to the system. This is the point of intersection here, which is the solution to the system. Okay, now, if you recall, we said you got to check that. How do you check it? You plug it back. So you're going to go back here. This is the check. And you're going to put it in the first equation, y equals x. You're going to say, does -1 equals, with a question mark here, -1? Oh, yeah. And then you're going to check the second equation. Y equals -2x minus 3. You're also going to plug in -1, -1. So -1, does that equal to? And you're asking a question, by the way, you're checking. It's not going to get offended if it doesn't. Nope, it won't. -1 minus 3. So that's a -1 equals 2 minus 3. That's a -1 equals -1. Yep, it does work. So I checked it on both, and it worked on both. And it has to work on both. If it works only in one of them, guess what, Johnny? It doesn't work. It has to work on both of them. For you to say this is truly the solution, then it has to work for both of them. And if you read carefully here, it says the solution appears to be. I think that's the solution. So how do you check it? How do you make sure? Well, that's what you do. You check it. You plug it back to make sure that you're confidently claiming this is the solution for that system. Okay. The second one here says solve the system by graphing. And obviously I'm going to be a little bit faster because you know this by now. So I'm going to go here and put this line here. Actually, I do have a graph. Let me actually. I'm gonna actually make it easy. Just please copy these for me. Copy these problems for me, because we're gonna use them. Copy the two equations. I'm gonna ask you in a second to give me the two equations. I'm going to a different screen here where I actually have a grid. So -2x minus 1. So now I could. There's this. There's that. Okay, let's say, what was the first one, you guys, in the system? Y equals what? What was the first equation in the system? Somebody write it down for me, please. Is it 2x or -2x? Come on, you guys. Can't be doing that to me. -2x minus 1. How about the second one? What was the second one? Or maybe I could use a different color for the second one. Y equals x plus 5. Okay, so remember we've done some of these, so I'm not going to go into details. Y equals mx plus b, but I know, for example, the first one is going to be for me, and this is when the software doesn't like it. All right, I'm a bit frozen here on this side. The software is. So let's give it a second to process. Yellow software. Hello, software. All right, let's see what does that. Oh, Lord have mercy. I have a frozen software at the moment. I apologize. All right. Okay, there's a glimpse of hope here. I need 1 minute of hope with Armani here. Anyways, I'm having a software glitch, which all of us do at one point. Come on. Juliana, deep breath. I need that. Hello. Okay. What could be done here? Okay, here we go. I guess we're back. Whew! Thank God. I just wanted to change the color. That's all I wanted. Hello. Okay, anyway, it doesn't like that. So, bear with me. I'm going to have to use the blue color for both of them. Okay? Here we go. Okay, good. Looks like we're doing something good here. That's funny. Okay, I'm glad. Okay, so now we're back. I'm sorry, guys. 1, and obviously the second one is 2. So I'm going to start at -1, and from there I'm going to go actually -2. Here's another 2 down, 1 and 2, and then go to the right one, and I'm going to graph. So I'll graph, pick my graphing tool, and connect these 2 lines here, just like that. Just like that, okay? And the second one is going to be the blue line, and the blue line is going to be at 5. I'm going to start at 5. So starting at 5, yellow, I'm at 5. There's a 1 and 2 and 3, 4, 5. I'm going to start here, 5. And it says I'm gonna go up 1 and 1, up 1 and then 1, and I'm gonna choose this blue thing here. So 1 and 1, and then I'm gonna connect my points. I think I'm crossing here somewhere. I should be careful with this graph. I guess I'm close enough for this graph. Okay, so that's how I graphed these 2 lines. When I graph them nice and neat, I should end up with a point on the left side that is actually a -2, 3. -2, 3 looks like is the answer for this guy. And how do I make sure it's the one? Well, you check it, Armani. You plug it. I plug it. Nobody has to tell me anything. I could check myself. Is this right? Well, check it. You check it and see. And it does actually check on both equations. Could it be only checks from one equation and not the other? Yes, of course. Then is it going to be a solution? No, it's not going to be a solution. It'll be a mistake. It's just not a solution. But for this example, yes, this is a solution since we graphed it and we also checked the answer. Okay, here's another one here. Solve by graphing. So one more time, please copy these down here for me because I'm going to ask you to give me these 2 equations in a second, okay? So y equals 1/3 x minus 3, 2x plus 4y equals 4. So actually, let me fix this one first. I want to fix number 2. Number 1 is ready for me to graph, right? See that? Number 2 needs a little bit work. So I'm gonna make this guy look like y equals mx plus b. And I could start perhaps taking the -x to both sides, right? -2x. Which will give me a y equals -2x plus 4, and that's going to be number 2. Okay, this is a 4 here. Okay, so I've got to take the first one, graph it, take the second one and graph it as well. Okay, so let's try that together. I'm going to go here and I'm going to depend on you now, and because you guys are awesome, you're going to tell me what was the first equation. Oops, that's lopsided a little bit here. It's okay, as much as I can. Okay, guys, what was the first equation? Okay, Kennedy. What was the first equation? Y equals what? 1/3 x minus 3. And what was the second equation after we fixed it? What was the second equation after we fixed it? 2x plus 4. Can somebody confirm the second equation, please? That's number 1. That's number 2. Since we're doing a system, do you think I'm missing something here? Somebody's saying this is negative 2x. Somebody help me out. For the system, am I missing something to indicate this is a system, not just separate, not just separate equations? What do I have to do? What's that thing that I put at the beginning of the system? Thank you very much, Natalie. You are paying attention. Okay, so everything is right here? Yep. Moving on. So I'll take the first one and I'll go to 3, 1, 2, negative 3. And from there I'm going to use the slope, up 1, and then 1 and 2 and 3. That's my second point for this guy here. I will come here and graph this line as careful as I can be. And then I'm going to move to the second one. And the second one's I'm going to start at 4. So here's a 1, 2, 3, and 4. And then from there I'm going to go down 2, 1, 2 for the slope, and then 1 to the right. Rise over run. In this case, you're not rising, you're actually going down and then running to the right. And this one, I'm going to choose a different color. So if I could use orange. Did it change or not? Yep, it did. So I'm going to go down like this. Okay. It looks like I am intersecting. I'm intersecting here, which is at 1 and 2 and 3 and negative 1, negative 2. Looks like 3 comma negative 2 is what we're proposing here. Okay, we are proposing this as a solution. We're not sure yet. So we go here and then we say 1/3 times 3 is 1. I've got 1 minus 3, that's a negative 2. Negative 2 equals negative 2 for this guy. How about the second equation? Well, again, substitute 3 and negative 2. 3, that's 2 times 3 is 6. Minus 2, that's 4. 4 equals 4. Yep, it does work, and this is a solution. Okay, here's an example for us, perhaps to be aware of, not rushing through things. But that's one clear example here that we have to carefully check the answer. Okay, so I know we have a limited time here, so I wanted you to try number 2 here. Plug in 2 comma negative 4 into this system here. Can you try this on your whiteboard? And tell me if 2 comma negative 4 is a solution. Yeah, Yurishi, that's exactly what we've done, yeah. I need to see more whiteboards, you guys. Plug in 2 comma negative 4 and check. Let's see who's going to be the first. We're checking number 2. We're plugging in number 2 into both equations to see if it's going to work. Okay, while you guys working on these problems, we are going to get ready to start the other section of today's lesson, which is inequality. Okay, Donovan, we'll give you time for questions, okay? And remember also today, I see that, Lindsay. Okay, good job there. So I'm gonna come back here, and this is gonna be actually yes, it's gonna work for both of them. And if I did ask for the notes to be uploaded, that's gonna be the quiz, the first quiz in these notes. Okay, here we go. Now we're gonna move on to the other part, which is the inequality. Okay. So inequality is exactly the same as lines, equations, with one exception. It's not just going to be a point of intersection. It will be something called region of intersection. So there will be, we call them overlapping regions. So basically, if you are aware on how to graph an inequality, you will graph an inequality, and obviously every inequality has a shading part attached to it. So you shade because you're in Cartesian coordinates, you're dealing with x and y axis. So there will be a region of solution when you shade. And what's going to happen today is you're going to shade twice. So there will be like twice or sometimes three times, where you will see this double shaded or multi-shaded region of solution. And that's going to indicate to you that there are solutions in that region. It's not one solution anymore. Okay, it's plethora of solutions when you do the inequalities. So please focus as you take notes. I'm going to start the warm-up. I'm going to also give you a couple minutes for that, and I'm not going to wait for a couple minutes, but when you watch this afterwards, that's what you need to do. Make sure that you actually do every single one of them to get you ready for, actually this one probably requires at least 3 minutes if you're careful. So now this one is for inequalities. This warm-up is for inequalities. This one is this warm-up is for inequalities. So I'm gonna pause about 2 minutes. Here we go. Watching this afterwards, obviously give yourself more time. But let me pick one of these, for example. I'm going to pick number 3, okay? Graph and shade the solution for number 3. So I'm going to take this dude here. And I need somebody to help me remember what is the inequality here, okay? Now somebody need to remember this one here. Or write it down in the chat so we can take a look at it, okay? 4x plus 3y is greater than 9. And I'm a big fan of... I mean, it's easier to, there's multiple ways you could go about this one of which is to find the intercepts, like do yourself the t-table, and then you could do it this way, or you also could, again, massage this to look like y equals mx plus b. Perhaps that's the easiest one to do. So I'm going to subtract 4x from both sides. And that's going to give me the 3y is greater than negative 4x plus 9. I will divide everybody by 3. I'm going to end up with y is greater than negative 4 over 3 plus that 3. Okay, please keep this in mind as I go to the shading part of my solution. I need to shade, obviously. This is not an equation. This is a inequality, and to solve an inequality, you've got to shade. That's part of solving an inequality. Okay, so I'm going to go here. I will put this one here, and then I'm gonna start graphing. Is 1 and 2 and 3. That's my first free point, and then from there I'm gonna go down 4. Here's 1 2 3 and 4, and then go to the right 3 1 2. I'm approximating here obviously because I'm using a I'm not using a grid. I can use that color here. Let me use this color here. All right. So that's going to be my inequality. Now there's two decisions you have to make. Okay, so first of all, you did massage it to make it look like y equals mx plus b. There's two decisions you already have to make for inequality, which you don't have to do it for equations. The first decision you have to make after you graph is this line that you graphed, is it shaded? Is it dotted line? Or is it a solid line? You have to make that decision. Is this line here solid, or is it dashed, or is it shaded? Well, what tells you is the actual inequality. Look at the inequality here. It's greater than. If you have greater than or less than, that means you are not including the line as part of your solution. So for the shaded or dotted line, you're going to have, you could use it for less than. Write this down, please. Or for greater than. But if you want to use the solid line, that means you have to have an inequality which has an equality in it. Meaning, it could be less than or equal to, or greater than or equal to. It has to have the equal to for you to claim it's a solid line. Solid line means it's part of your solution. Okay, solid line means it is part. The line itself is also part of your solution, not just the region, but also the line. You're including the line. So back to my question here, to this inequality. Do you think I would have a shaded, or I would have? I'm sorry. Should I have a dotted line, or should I have a solid line? That's dotted. So and I have to excuse myself here, and I really have to dash this line, make it dots, because not all of it is included. It's not included. The line is not included. The second decision you have to make is this. Second decision, which is also important, that you don't have to do for equations, is the following. Where is this region of solution? Remember, you told us there's a region. There's multiple solutions, not just one. So you do this by actually testing a point. You test a point. And the easiest point to test is 0, 0. You don't have to test this point. I'm just saying that's the easiest to test. If you test 0, 0, and it gives you a happy face in that region, that means this region, this is where you shade. That's where the solutions are. If it gives you a frown face, like what you're doing, then you shade the other side of it. So for example, here, if I tested 0, 0, I'm going to go here and put 0, 0 for x. So 4x plus 3y, is that greater than 9? I'm testing, okay? So I'm going to say 4 times 0 plus 3 times 0. Is that greater than 9? Let's check. 0, 0, that's 0. 0, is 0 greater than 9? Is that true? That's not true. I'm sorry. So the region that you picked, which has the 0, 0, does not work. Please do not shade that region of, or that side of the line. Shade the other side. Oh, okay. So this is the other side where the solutions are. Not the side of 0, 0. If the side of 0, 0 give you a true statement down here, true inequality, then that's the side you shade. If not, then that's not the side you shade. Okay? So for inequality, you gotta have to make two decisions. One of which is it dashed or is it solid, dotted or solid, and then the second decision, where should you shade, and you could test a point such as 0, 0. What if the line actually passes through 0, 0? I would probably test a different point, maybe 1, 1, whichever. I mean, you could test 1 million, 1 million, 1 million to 500, but go easy on yourself. Okay. All right. So here's some vocab. A system of linear inequalities is a set of two or more inequalities, contains two or more variables. Solution of a system of linear inequalities consists of all order pairs that satisfy. The word satisfy means you plug it in and it makes sense. And all linear inequalities. Remember, this is going to be in a video, so don't rush through writing. You could write like shorthand writing, and then when you have the video, you could do that. Okay, so I have the system. Tell whether the order pair is a solution to this system. Well, obviously, again, I'm going to plug in the point. This one does not require graphing. They're just saying, can you plug this point and make sure that it works? Okay, and if I actually did that, I'm going to plug -1 for x. So that's going to be -3 for number 1 here. That's going to be -3. I'm going to actually test it back here for number 1. I'm going to say this is y is less than -3x plus 1. And by the way, when you test this, you usually just focus on the equality sign, but we're going to take a look in a second. So I have -1 less than or equal to -3 times, I'm sorry, I made a mistake here. This is actually -3. -3 is less than or equal to -3 times -1 plus 1. And then if that is true, -3 is less than, this is a 3 plus 1, that's -2. Is -3 less than 2? So let's focus just on the less part. Is -3 less than 2 on the number line? Yes, it is. So that one would work. How about the second one here? Let me change color, and I'm going to do the second one, number 2. It's number 2 here. Okay, so I'm gonna, y is less than 2x plus 2, and I'm gonna test again the same point. Remember, given this point here, so I have a -3. Is that less than 2 comma 2? I'm sorry, times -1 plus 2 is -3, and this is a -2 here plus 2. That's 0. Is -3 less than 0? Is -3 less than 0? Yes. So I would say this guy is a solution. So then you could say then, and you could use, by the way, these 3 dots in math means therefore or then. -1 comma -3 is a solution. What makes you confident, Armani? Well, I checked it and it works for both of them. Okay, so that's what we need to do. Check it for both, and it checks. So this -1, -3 satisfies, means it plugs in, and its quality is true, and that's why it's a true one. Okay, this is the easiest. Why don't you guys try this one on your own? Okay, try this one. 0, 0. You are checking 0, 0 in these two inequalities, and tell me when you're done if it's a solution or not. You're testing to see if 0, 0 works for this system. All right. Use the chat, use the whiteboard. Okay, I see a glimpse of hope here. One is saying, come on, I don't want to say it. I want to hear it from you guys. Oh, that's a big no-no. So that means when you checked it, it did not make sense. It did not make sense in the first one. It made sense in the second one. But guess what? Because you have a system which is connected, that means it has to make sense on both of them. It has to satisfy both. Or if you have 3 equations, it has to satisfy all 3 equations or 3 inequalities. Okay, I'm going to leave this one for you once you watch this afterwards. So you pause here, and then you try this on your own. And when you try it, you're going to find out that this one is a solution. Okay. So how do you graph a solution for inequalities? Okay. Well, here's the first example here. It says graph the system of linear inequality, give 2 order pairs that are part of a solution, 2 order pair that are not part of a solution. And looks like this is going to be my last example in this lesson. So I'm going to graph this. and looks like it's actually ready for graphing. So I'm gonna go here and just give myself the liberty of having the x and y axis here, and I'm gonna do the first one. Y equals a number. That's an equation. I'm sorry, that's y equals y less than or equal to 3. It's an inequality, but I'm gonna try to, as always, you try to graph the line itself. So y equals 3. How do you graph y equals 3? Is this horizontal or this is a vertical line? Is y equals 3 a horizontal or a vertical line? Yo. It is pretty much a horizontal line. Horizontal line. So I'm gonna go here at 1 and 2 and 3 and have myself y equals 3 as a horizontal line. Okay. I have to make a decision. Is this a solid or is it dashed line? Solid or dashed? That's a solid line. That's a pretty solid line. There's a less than or equal to. So that's why it's solid line. The second one here I'm going to graph. And the second one I'm going to have to start at, where do I start for the second one? What do you think I'm going to start for the second one? Hello? Where do I start for the second one? Up on 5. So 3, 4, and 5. I'm going to start here. And I'm going to go down 1 to the right one, down 1 to the right one. I'm going to come up with this good looking line. Ooh, attractive line. So let's see. I actually could make it look like that. Here we go. Now the question is the second line here that I had, remember the two decisions you have to make? Is the second one here, is this solid or this is dash? Is this dotted line or this is a solid line? Yes, it is a dashed line. Why is that, Armani? Well, look at the inequality. Does it have an equality here? No, it doesn't. It just says it doesn't have an equal sign. It just has greater than. So the line is not included. The second decision, if you guys remember, I need to shade. So if you need to shade, I would test points. So for the first one, I'm going to test 0. Remember 0, 0 point? That's your best friend here. So if I put 0, is 0 less than 3? Is that true? Is 0 less than 3? Is that true? Guys, let's focus here. We need to finish. Is 0 less than 3? Yes. So anything on this side is part of my solution for that guy. Anything below, the orange is part of my solution. Okay. Now let's test the region for the green one. This green one here. What do you think where do you think I should test? Well, again, 0, 0, Armani is the easiest one. So is 0 greater than 0, obviously, and then 5. Is 0 greater than 5? Is 0 greater than 5? That's the question. Nope, it's not. So it's not going to be this section. It's going to be the above the other side of the line. The other side of the mountain. The other side of the mountain. The other side of the mountain. To see what he could see. Anyways, so if you looked closely now, you're going to see the double shaded. There's a double shaded region, not just 1 or 2. And it's going to happen. It's going to happen. Okay. It's going to happen somewhere down here. It's going to happen in the double shaded region. What's going to be here? See that thing? See that area? See that area? Anything in this region should work for you. But not above, not below. Just that. This is just that region that we have for solution. So here it is, the double shaded region down here. And you could test points. 8-1 is one solution. And then 6-3 is a solution because it's a solid line. Other points are not. This one is not, and obviously the last one is not. This should conclude our lesson today. You guys have done an awesome job.